Hey serverless friends, and welcome at another Azure Functions University lesson. This time we're going to talk about HTTP triggers in Python. And I hardly know any Python, but luckily I have Dana Arowska here, or Dana Arowska here, who can help me with this. Hi Dana, welcome. How are you doing?
Hi everyone. Yeah, I'm going good. How are you?
I'm doing well. I'm doing well. Yeah, I was looking forward to making a new lesson for Functions University again, especially for a language which is still new for as Functions University. So I'm very happy with your contribution. So yeah, thanks a lot for being here today.
Yeah, thanks for having me. It was a lot of fun preparing this lesson, and yeah, looking forward to the workshop part of it as well.
Cool, very cool. So how long have you been using serverless?
I've been using serverless for a bit over 3 years. I'm a data engineer, and I use it quite a lot in my day-to-day job. Started with Azure initially when I became a data engineer and
Hmm.
built Azure Functions there. Currently, I'm working with AWS, and there we have Lambda, but the concepts are very similar. The most common way I used it so far is building functions that detect changes in blob storage. And then I built a function that processed the data that was uploaded there and placed it usually in a database, but sometimes
Right.
in other formats as well.
Cool. Yeah, that sounds good. And hey, you're using Python, and did you already know Python before you started with serverless, or did you?
Yes, yeah. First I did mostly like a Python backend role, and then I kind of migrated to a data engineering role.
Okay.
Yeah, so mostly use Python with serverless,
Hmm.
I would say. But yeah, before that I was a Java developer, so combination of Java and Scala for the
Ah, right.
other backend
Yeah.
jobs that we built.
Hmm. 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 Oh, cool. Yeah. So have you used Java then as well in serverless, or not? Of only
No,
Python?
no, that was only Python in serverless. Java and Scala was for other like backend processes,
Right.
but not
Yeah.
necessarily serverless.
Okay. Cool. Thanks. Before we dive into the lesson, I briefly want to share my screen. Let me add this here. And want to show everyone that if you go to this link, bit.ly az-func-uni, you'll have all of the lessons here in all of the languages, which are becoming more each week. It also links to the YouTube channel, and maybe you're now watching on YouTube. We're also streaming on Twitch these days. So this is the best place for you if you want to learn about Azure Functions. Then please visit this repo. We have a lot of lessons already. We start out with .NET Core. I am still processing them, rewriting them for .NET 6, so that will happen soon. We have some TypeScript lessons, some PowerShell lessons, and now also a Python lesson. If you want to contribute, please do. If you want to contribute, first have a look at the existing issues, because there are a lot of issues already created, which are mostly content requests. So please, you can pick any one of those as long as someone else hasn't started to work on it. If you don't see a topic that you want to work on, feel free to create another issue, and then we can discuss how to best proceed with that. All right, let me remove over to you, Dana.
Yes, thank you. Um, yeah, so today I will talk about serverless Azure functions in Python, which are invoked with HTTP triggers. Um, I think that's a great way to start because HTTP triggers are, well, not so complicated to set them up. Yet they're very powerful. We can do a lot of different things with them. We can play a lot with the code. And testing it locally is also can be done in like a couple of simple steps, um, which is useful because today we will only focus on testing them locally. Um, so HTTP triggered functions are functions that receive an HTTP request as an input, and then they output usually an HTTP response, as we will see. I think the best way to see how we can use them is just jump into it right away and see some code. But first I will go to the prerequisites and see what we need to have set up locally to get started.
Cool.
This is the repo that Mark just showed. I have a separate lesson just for the prerequisites. I will not install each one of these locally today. I already have that done, just in interest of time. However, if you click off any of these links, it will take you to a website, and there you can just see how to do it for your own operating system. If you have any questions, you can just reach out. But usually it's quite straightforward, both for Mac or Windows or whatever you're using. So yeah, let's get started with this list. The first thing in the list is Node.js. We need it because we are going to use the package manager npm. We use it to install Azure Function core tools. We're going to see what that is in a bit. But this will help us set it up locally. It's very important to install a long-term supported version because Azure Functions only support long-term support versions of Node. If you click on the link, you will see which these versions are, and you can set it up. Of course, we need Python. If you don't have it already, I used version 3.9. However, any more recent version should work with this code. So 3.8, 3.7, or that should all be okay. As an editor, I'm going to use VS Code. VS Code is great because it comes with a lot of extensions we can use to build the serverless functions. One of them, for example, is the Azure Function extension. With this extension, we can create a template for the function, we can manage it, we can develop it further. So it's super useful. And then furthermore, we need the Azure Functions core tools. This is a command line interface. I will use this to start them up locally, and then we can also test them like that by starting up locally. So no deploying to the cloud today, actually. So it will do just local testing. To invoke the functions, we need some form of REST client or HTTP client. I listed two options here. We have Postman and we have the REST client of VS Code. Both are nice. The REST client allows you to automatically store all the requests you make and then commit them to Git, and then other developers can see them as well as yourself in the future if you want to recreate all the requests you made. Both are useful. I'll just use Postman in this case because it's I would say, more simple, and we want to keep things more simple today. You also need a virtual environment for Python. If you use Python, you're familiar with it. This is like an enclosed environment for all your dependencies. So if you have multiple Python projects with conflicting dependencies, it's quite nice to have this set up because it allows you to isolate them and work with multiple package versions at the same time, just by activating the environment. I described here how you can set it up. You need to install it first, and then initially you have to set up the first version with the terminal. And then VS Code automatically picks up that you want to use a virtual environment, and every new version, every new project that you open of the project of every new version will be automatically set up. So yeah, if you just open a new project, it will set it up for you automatically. And finally, I have the Azure CLI here. I have a lesson about deployment to the cloud, but this is an optional one. This command line interface will allow you to deploy all the stuff we tested locally, actually to the cloud. So if you have an Azure account or you would like to create a free trial one, you can do it and follow this lesson for deployment to actually deploy them to the cloud.
I love the Azure CLI indeed, and it's nice because you actually prepare two lessons because deployment is a separate lesson. So thank you for creating two lessons already.
Oh, really? Okay, didn't know that. I had it from before, so I thought I can just include it here.
Oh, perfect.
All right, great. A bit about the workspace. I think Mark a bit showed already how everything looks like, but we have three folders, one for these markdown files and the lessons, and then we have source and test folders. Splitting the code to source and test is a good practice, and in Python as well. We want to have the development code separate from the tests. So we can run all the tests at once, and also if we want to run the code, we can do it separately. If you're stuck while you're doing some of the lessons, you can take a look at the source directory or at the lesson. But yeah, I encourage you to try first on your own and see if you can solve it. But if you're stuck, yeah, feel free to refer to the source folders. Right, with that, I'll jump into the first lesson over here. This is a useful feature. If you want to go to a certain topic, you can just use this toggle here and jump to it. But at the moment, I will just start with creating a function app. I'll just split my screen in half. Let me see. I don't have. I'll just pull this over here. Okay. Oops.
Yeah, I'm also very happy with all these tiny features that GitHub keeps adding in, like the indexing,
Yeah,
and,
definitely
the
very
table of
useful.
contents, and that all these small features, but they make it so nice for us to use. Yeah.
I'll just let me see. Sorry, I have the wrong window open. I'll just.
That's fine.
I have this one. We don't need at the moment. This is the final version, and for now we just want this guy. A bit new to this. Takes me a bit of time to split the screen properly, but almost there.
I'm still getting used to my
Okay.
Mac, which I received
Yeah.
like a month ago. So I still have a hard time remembering
Yes.
all the shortcuts
All
and
right,
stuff.
there
So
we are. Okay, so I'll have the Visual Studio Code editor over here. And then on the left side, I will just have the lessons so we can kind of follow along
cool.
what we're doing. We'll just start with creating a simple template of the function. I have my terminal over here, and I'll just create a folder called Azure Demo. Okay, and then I'll just open this empty project here. All right. So this is completely empty. We are starting from scratch. I already have the Azure Functions extension installed here.
Mm-hmm.
I'll click on it. I'll click Create New Project, and I'll select the existing project. By the way, you can also do this through the terminal. Just type func new, and that will open a prompt, and you can do the same steps I'm doing here just through the terminal. We have the languages here. I pick Python, and then we pick the interpreter version 3.9. And now we have a list of triggers here. Yeah, here we'll just pick HTTP trigger.
Mm-hmm.
And then for the name, I'll just copy it from here. And press enter. Now we have the authorization level. This is not so important if we just test the functions locally, but if you want to do the deployment lesson, it might be nice to know. Authorization level is how we would like to authenticate the function when we are invoking it. And if we want to use API keys or not, and then what kind of API keys. Function is the default one. There we need to provide a function level API key, and we have two kinds there. We have function keys, which if you use, you can only invoke a function that they are meant to. And then you have a host key, and the host key is for the entire application, which means that application might have one or more serverless functions. And this is the default one, as I mentioned. So if I don't pick anything, we will use this one. Anonymous means that we don't require any keys. So if you just make a valid HTTP request, we will trigger the function. Admin, I didn't use this one, but I know there is a special kind of a host key called a master key. And this allows you a host level access. And on top of that, you can also get administrative access to the whole application and all functions in it.
Yeah. So usually stay away from that if you don't really need it. Yeah, exactly.
So yeah, for now we're just gonna use function, and what this does is creates a project for you, and it's creating a virtual environment automatically. Okay. You see here now we have a new project created with proper file structure that is used to create a serverless function. I'll just briefly go through every file and folder in here, just so you're familiar with the whole file structure. We will not edit all of these files, but just I think it's nice to know what's inside. So this is the virtual environment. As I mentioned, this is the encapsulation of all the dependencies. So all the dependencies that you install will be installed in this virtual environment, very common for Python. We have a VS Code folder, because it's a VS Code project related with the virtual environment. We have the requirements file, and here you list all the packages that you would like to install within the virtual environment. So for now, we only have Azure Functions, but we can add more as we need them. let's start with the function.json file. This file configures the endpoint for our HTTP calls. The first value here is the script file, and this is the entry point for our application. So this has to correspond to the init file that was created over here, if that's the file that you would like to start initially. Then we have the bindings. Bindings are a simplified integration of the input and the output of the data that goes into your function. So as you see, you have both input and output bindings. Yeah, for now, we only have an HTTP binding, but you can add as many as you want. Both input and output are mixed. So you can have a binding for webhooks or blob storage or databases if you want to get that kind of data in or out from your function. But yeah, for now, let's keep it simple and just have HTTP bindings. We can see the type of the trigger here, and we have an HTTP trigger, which means that this is the method we will use to invoke our function. Important to mention, we can have only one trigger for our serverless function, but we can have as many bindings as we want, as I mentioned, but the trigger has to be only one and unique. This over here is the name of the data variable that we pass to our function that we came to it. Keep this in mind, we'll see in a bit like where we use it. This is the authorization level that I just talked about, and it's set to function. So if we picked admin or anonymous, this would have been updated. And then we can use two methods to call our function. We can have get and post for now, and we can add or remove them as necessary. We will see that like in a bit, like how we can modify this part. Okay, that's all about the function file. The host file over here is like a global configuration for our entire application. And here, for example, you can set the logging level. So we have application insights, and we can define what kind of type of data we want to flow into our application insights. By default, we don't want the request data to go in, because then we will have too much data going into our application insights, so we exclude them. And then we have the extension bundle value here. This is extensions for bindings, I think. And this is, yeah, I understand it kind of as a package management. It can extend some of the packages that we have already installed. Okay, that's all about this. This is not super important at the moment. We will not edit it anyway, but good to know. Then we have the local settings file. So when you run your function in the cloud, all the secrets that the function uses, like passwords or connection scripts, are stored in the app settings. And we also need to store this information somewhere locally. And we do that in this local settings JSON file. So the values object can contain any secrets that we want to use in our function. So if you want to use some passwords or something, you can just add it here. And you can see this file is not committed. That's because we don't want to push this accidentally to a remote repository and expose our secret. So by default, it will stay uncommitted. And finally, we have the hello world HTTP trigger. This has the same name as the function we created. And inside, we have the init file. We'll just make this a bit smaller. I'll start just line by line and go through what's happening in this code over here. So first of all, we import two packages, the logging and the Azure Functions package. And this package allows us to process the data we're receiving and create the appropriate output. We have a main function over here, and this is the only function we have at the moment. It receives a HTTP request as an input, and it returns a HTTP response. And you can see that the argument we give here is rec or request, and it was also defined over here. So it matches the name value defined in the function.json file. And then we have this bit of code over here. The first line responds to getting the name argument from a get response. It's going to be a bit more clear in a minute, but for now, you just need to remember that with this part, we check if, in case we got a get response, if we got a get request, if this request contains a name argument in it. And then we have this bit of code that corresponds to a post request in a way. And in here, we check if the name wasn't found before. We check if the request contains JSON. And then if this bit of code executes without any errors, we go to the else statement. And then we get the name value from there. And if we get any kind of exceptions in this line, then we will just exit this if statement. So if we didn't find anything here and we didn't find anything here, that means that the name argument wasn't present over here, or that it was maybe found over here. So then we have another if-else statement. We check if the name was found, and then we return a success message, including the name that we found. And then if we didn't, we return status code 200, which means just OK. And we ask the user to pass a name in the query string or the request body. We'll change this in a bit because we don't want to have a status code 200 if the name wasn't present. But for now, we'll just leave it as it is. Yeah, so that's all about the function structure. I will just start it. You can do it very easily. You can just cd to Azure demo. And from there, you can run func start. And then this will start up our function locally. And you see it generates this bit over here, which contains the name of the function and the methods we can use to invoke it. In this case, it's get and post, as well as a URL we can use. I'll open Postman. I have it set up over here. I'll paste the URL, and I'll try initially to see what happens if I use a get request. And then you see that it executed successfully, but it asks me to pass a name, and the status code over here is 200. I'll just pass a name over here and click send again. And you see now it outputs a different response, the one for where the name is found, or this one. Okay, I'll use post method now. And I'll trigger it once without any arguments in it. Again, I'm getting that I need to pass a name in the query string. So if I click raw now, and then I select JSON from here, I can make a simple JSON and click send. And you see again that now the function executes successfully, again with the 200 response, but this time it found the name. So that's great. This works exactly as we expected.
Yeah, cool.
So that's the first bit. This was more like, yeah, just so you get familiar with the structure and yeah, what's exactly in the init file. So we are able to tweak it in the next part. In the next part, I'm going to show you how, yeah, easy it is to alter the code and alter the requests we accept to invoke the function. So now I would like only to receive get responses. So I will remove the post method from this list. Mm-hmm. And then I'm going back to the init file. So as I mentioned, this part corresponded to a post request. So I'll just delete it. And then we want the error message to be a bit more clear. So I'll alter this a bit. I'll set the status code to be 200 over here and 400 here. And I'll alter the error message a bit as well. I'll just leave it like this for now. So in case we don't find the name parameter inside our request, then we want to return a 400 status code, which means the function failed. And we ask the user to pass a name in the, well, in our case, only in the query string. All right. So now we expect to only see a get method when we invoke the function again, and we expect the post method to fail. Okay, so let's get the terminal again. I'll just restart the function. And now indeed, you can see that for the same function, we only have a get method. The URL stays the same. So I'll just leave it like that for now. Okay, so I'll try to make a post, and then I'll get 404 not found because it doesn't exist anymore.
Oh, yeah.
And then I'll run the get command again in the same format as we did. So this works as expected. But now if I don't pass a name in the query string, I get a 400 status code bad request because we changed the way we output the error. We don't have the 200 status anymore. I think this is a bit more clear because we do miss the name from the query string. So indeed works again as expected. And yeah, we just saw that it's not, it's super easy to modify which methods we allow or we don't allow to invoke our function.
Cool.
For the next bit, I will return the post method. And we want to make this a bit cleaner, and we want to see which method invokes our code and like have an extra if else statement. So we can achieve that by using the method field of the rec input. So this field can tell us what kind of request we're receiving. So we can check if we're receiving a get or a post request, and only invoke the code we need. In the past, we invoked both the get and the post code in each case, which is not ideal because if we have a bigger application, we want to make everything as minimal as possible. So I'll just copy this bit again. Okay, it didn't get formatted. So I changed a couple of small things over here compared to the initial template. The first thing is, of course, we check the method type. We check if we're getting a get or a post. This stays exactly the same. We check again if the query string contains a name parameter. And after that, so if it's a get, we'll exit here. However, if it's a post, we again do the same thing. We check if we are receiving a JSON. And if it is a JSON, then this part doesn't get executed. We execute the else statement. And in this else statement, we retrieve the name from the body. However, if this part fails and we actually invoke the exception, then we set the name to none because we want this part to be triggered. And we want to let the user know that the name wasn't present in the body. If we just set this now to pass, then we risk getting a, not found method error or 500 like bad request was made, which we don't want because the post method is defined now. So we have to set the name to none in this case. So we do get the proper status code. An extra improvement I can see here is, and like making the code a bit more structured and readable, is making an enumeration for the get and the post strings over here, as well as for the status codes. So we can create an enumeration for get and post, and then instead of hard coding them here, we can use the enumeration, and then we can have an extra one for the status codes, and then we can just use it instead of just having these values over here. In my opinion, it would make it a bit more readable, but for now we want to keep it as simple as possible, so I'll just leave the code as it is. So what do we expect to see now? Again, we want to see both get and posts there when we start the function, and when the body is not found, we expect to get, when the name is not found in the body or the query string, we would like to get this message, and when it's found, we'll get this. All right, we can start up the, sorry, I just want to actually do this bit as well. I think we need to make this a bit more specific as well. This bit will just make the error message a bit more specific, and it explains what we need to do for both GET and POST requests.
That is very useful indeed. Yeah, that's a common mistake, right? You put out an error, but you have no idea how to fix it.
No idea what it is. Yeah. So yeah, indeed, this part will help us be a bit more specific about what's going wrong.
I like it. Yeah.
Again, let's start it up. Okay. Again, now here we see that we are back to having two methods, and the function name stays the same. So I will not copy it again. So I will just run it again a couple of times. Doesn't seem like it's saved. Let me just restart quickly. Okay, let's try one more time. Okay, now we get the proper error message. And we see that we need to pass the name in the query string for GET and pass a name in the body for a POST request for a personalized response. I'll just, again, test it out a bit. Pass a name argument here, and indeed this works as expected.
Yeah.
Let's try it for a POST. Again, now if I run it, I get the proper error message over here. And then I'll just click raw and JSON. And again, yeah, this is working
cool.
as expected. Yeah, so what we did now is we made the code a bit more structured. We do some checks for the method type, so we don't run extra code when we don't have to. And we made the error message a bit more specific. And yeah, we want to make sure that the output of the post is as expected when no name was present in the JSON body, or we didn't pass any JSON. So that's all. Yeah, that's all very nice. We already have something a bit more, readable and I think a bit more clear. And yeah, we saw now how easy it is to just delete one of the methods and add them back. So if you need in the future, like you can also add more, like following this template. For the fourth lesson, well, I wanted to follow the structure that all lessons have, and like, yes, some languages have type checks. Python unfortunately doesn't, so that wasn't possible for this lesson. But I thought it might be very nice if we tie the JSON response to object of a class, and then we make sure that in a slightly different way that it's present. And then we can also have a bunch of methods we define for the class and make the code a bit more production ready. For this particular lesson, I decided to use something called a data class in Python. For those that are not familiar, that's a class that's very useful where we mostly want to store state or data, and we don't have a lot of logic inside. And in this case, I will not write a lot of logic. We will just store the data output of the request. So yeah, I think it's a good use case for it, since we will not have a lot of heavy logic. I'll just import it. Okay. And I'll just copy this bit. And in this case, by the way, oops, we want to have only post requests. So I'll also edit the source code a bit to only accept post requests. So, okay, I'll remove this bit for now. And then we go to function JSON, and we are going to delete the get part over here. And now we only have the piece of code that's used for finding the name parameter in the post request. And now we want to create a instance of this class. So we'll do it like this. But this is the same. So first of all, we need to make sure that we pass the right value when there is none. And then same over here. And now we can simply check if person.name is present. I will just rename this so it's a bit more clean, because this is an instance of the person class. I will just call it a person.
Cool.
Yeah. I think it's a bit more, bit more clear. And yeah, we check if the instance of this class contains the name value inside.
Yeah.
And I also need to do it over here. I'll just call it person.name. Yeah, and now if we want to also implement some extra methods or extra logic over here, we can do it by just adding some methods in this class called person.
Right.
But data classes are great for just storing data, like in this case. So if you have a more complicated JSON, you can list more fields here. We do define the type here, but this is not type safe. So if I passed an integer, let's here, or a Boolean for a name,
that will still work?
It will still work. I can give you a small demo, but it's still nice because in a way it documents.
It's nice and describing. I like it. Yeah, exactly. Yeah. Okay.
And at least you can make sure that all the fields are present. But yeah, Python is not type safe, so this will pass. All right, let's test this bit of code.
Yeah.
I'll start up again. Just a moment. I actually forgot something. I wanted to show you how it would look like if I have two functions. So
good point.
I'll just rename this bit. I'll leave this for now. Actually, this can be the custom trigger. Both of them now contain the same logic, but yeah, nice to see how it would look like.
Because a function app can contain multiple functions, so it's nice to be aware of that structure. So
indeed, I created another one over here. So we have the custom trigger and we have the hello world, and they can have different logic inside, of course. If you invoked, you can invoke one of them. So now we'll just invoke this one. And you see both of them have just post. So, okay, let's copy this guy, post it here. So again, I can just try to do a gap just to show you. It's gonna be not found.
Yeah, it's not allowed.
So for post, I'll just pass the name value over here, and then it works. But yeah, indeed, if I just pass something here, like
not a string value, you mean?
Not a string. It will still work, but nice to at least have it tied down to a class. And
this is good to know, this information. Okay.
And then indeed, if we don't pass any value in it, we will get an error, and that's basically this fit being invoked and assigning the value of name to none. We already have it as a default to none, but still nice to have it
explicitly. Right.
Here.
Cool.
And parallelly, you can also, in a different window, you can also run this one, but because it has at the moment the same logic, no need. I just wanted to show that you can have multiple functions within the same application in this case. Which is quite nice. All right.
And the going back to the data classes, so that's a separate Python package that you need to import first before you can use it.
Right? Indeed. I have it. I have it already in the lesson added to the package over here, so the requirements package. So if you just run pip install, it will install it automatically. I think it's already comes in certain Python versions. I think it might be already there as a default package, but I'm not 100% sure about that.
Okay. That's good to know. Thanks.
That's all for the lessons. We prepared homework for you as well.
Yes.
After going through all of this, it might be nice to just see how much you remembered, how much you learned. The homework is a simple natural language processing application. we provided a script that detects stop words in English. You can see what a stop word is over here. And it detects it from a text file. I already provided the test data. I already provided everything you need. You just need to figure out how to use this custom code and import it into your function and make the code a bit more modular, as well as how you can tweak the output you're giving here. Like now I'm just passing one value, but you can also pass many and you can format it nicely. It's a very nice, like I think, subject because you can play a lot with it. You can find your own custom applications that you would like to test and like expand on it if you feel like you would like to try out more things. So we're starting with a quite not so complicated application, but you can build on it and
and
maybe
it's still very much a real life function. So so this hello world is of course still very basic, but if you like just a bit more, then this homework assignment is really nice to try. Great.
So you can kind of even see like in a way like a real life machine learning application, like how it would look like. It's serverless. So that's all for the homework. You have the steps explained here, but if you get stuck, you can take a look at the solution. And then I have this bit over here, which is about deployment, but this is optional. If you want to create your own Azure account, I think you can create one for free with like $200 credit on it, which is more than enough for this lesson. But you don't have to do this. So using the Azure CLI, you can log into your Azure account. And here I'm not going to go through all of them, but you have step-by-step everything you would need to do to deploy the functions you created to the cloud. And then in the end, after following all the steps to create all necessary resources in the cloud, you will get, again, like a URL. You can just post in Postman and test it out to see if it works. So if you are interested and you have a bit more time, you can take a look at this lesson as well.
And we'll probably do a separate recording for this one.
Just wanted to mention it, nice. Briefly,
But it's good that you already mentioned it. It's good to include this.
I wanted to show one more thing. I will just close this for now and open another workspace, just like the complete code that we have already. Let me see. I just want to show the CodeTours that we built. Okay, so this is the Python workspace in VS Code, and we created the CodeTour files for you over here. So I'm not sure if you're familiar with it, but if you just start them up, let me see. Shouldn't this?
Is the
I'm in the wrong. In the extension. Thanks. There it is. So just by clicking on the CodeTour extension over here, I'm not sure if this comes. I think this is something you need to install if you don't have it already in VS Code. But
yes, but I think we added it as we added it as a recommended extension. So if you don't have it, Visual Studio Code will ask you, do you want to install this extension? And we recommend you that you do.
So this will guide you through everything I explained already. If you just click, you have one per lesson. So if you just go through it, it will guide you through all the files and everything I already explained. And you already have all the commands I used here. You can just copy paste them or click on them and they run. So if you want to refresh your knowledge about certain point, and you don't feel like watching the recording again, you can just use the CodeTour to do so. So quite useful.
This is a very useful addition. So thanks for putting the time in to also make the CodeTours, because it is quite a bit of effort to also write that down. But it's much appreciated indeed. It's really nice. Thanks for that.
No worries. I think
yeah, we're done with the lesson, right? So yeah,
So,
what is important to realize, because if you do clone the entire repo, we
yeah,
have so many lessons and so much source code across different languages that it is important that you, for this lesson,
yeah,
open the Python workspace, so you
yeah,
only
yeah,
have the lessons available to you that you actually need.
yeah, yeah,
So
indeed. So just navigate to this folder and pick this. Otherwise, yeah, you get everything open and it looks a bit, yeah,
exactly, then there's just too
odd.
much
Yeah,
information, and then also some code samples will not even execute, because Visual Studio is
yeah,
then a bit lost, because it can't choose which runtime to use, for instance. So make sure you use the workspace files. Excellent. Well, thanks a lot. Yeah, like I said, I'm very happy that we can now be extended Azure Functions University with Python. So yeah, I'm hoping that either you can add some more, but I'm also asking it out in the open if people want to contribute Python lessons or any other lessons that Azure Functions support. Please do raise a content request issue in GitHub. Let me show you the link again. So please go to this link, open a content request issue, and I'm very much open and will be very happy if you want to contribute a lesson, and you can co-host the lesson then as well, if you like to. So yeah, Dana, thank you very much for your contribution. I think it was a very nice lesson. So I've used Python maybe like very few times, many years ago, but it does look very nice in combination with Azure Functions. So I will try out also your homework sample.
yeah, great. Thanks for having me again.
Yeah, no worries, indeed. And I hope to see you again in a new lesson.
Yeah, same.
Okay, hey,
Likewise.
thanks everyone. Until next time. Bye bye.
Bye bye.